Hello everybody and welcome back to Maths Miss Buick. This is the third video where we explain polar form. Just to recap, polar form is r cos theta plus I sine theta. R is the modulus and theta is our angle. So in our question we're going to be looking at today, we have z is equal to 1 minus root 3i. So let's begin by plotting our complex number to see what quadrant it may lie in. Well, this is our real axis here and this is our imaginary up here. So 1 is positive, so we know that the real will be along this axis here, and then our negative, root 3, is down on this part of our axis. So then we know that our complex number is in the fourth quadrant. So let's label our reference angle alpha. Okay, so now let's begin by calculating our r value, which is our modulus. So we have r is equal to the square root of a squared plus b squared. So we have the square root of a, which is 1, to be squared, and negative root 3 to be squared. So we get root of 4, which is 2. So root of 4, which is 2. Now we're going to find what is our alpha value. So alpha is equal to tan inverse of b over a. So as I said in previous videos, the a and the b are lengths. They're deducted from, we'll say, Pythagoras. Opposite over adjacent is tan. And you can't have negative lengths. So let's keep the lengths positive and only input positive values. And then we'll talk about how we can figure out what is the angle using our notation up here. So our b is root 3 and our a is 1. So again, you go to your calculator and you type in tan inverse of root 3. And you can see here, we get out pi over 3. Pi over 3. Now, so this is the value of our alpha. So now let's look at our rules up here. Well, we're in the fourth quadrant, and what we're telling you is theta is equal to the negative of the reference angle. So in our case, our theta will be equal to the negative of the alpha. So that means that our theta is equal to the negative of this. So minus pi over 3. So now we have our values. We have our r, which is 2. And we have our theta, which is minus pi over 3. And we're going to input then values into our r cos theta plus I sine theta. So r cos theta plus I sine theta. So there we have our polar form for 1 minus root 3i.